The 2 cosine and the negative 1 cosine?
Oh, yeah.
My kiddos out there that are saying first times last or A times C, what are you telling me?
Multiply the 2 by
So we stole the
what was that?
ax squared plus bx plus c, the a and the c. First times last or A times C goes up top. So 2 times negative 1, negative 2. This is my middle, like it always is. This is my middle coefficient, which would be the 1 by the cosine. Because the cosine is like, we did this in class. For those people that didn't like the cosine, we ignored him. So the other way to do it is you can say this is 2 somebody squared plus that somebody minus 1. So if you like it better, you can ignore the cosine and do the same thing. You would still do your first times last. You would still do your 1. You would still get 2 negative 1. Just then you could ignore the cosine and say 2u minus 1u. So if you like this better, you can do this also. And what's going to end up happening is that you get the exact same thing, just at some point. At some point, you've got to get the cosine back. So at this point, 2u minus 1 times u plus 1, then when you come over here, you have to put that cosine in that spot. Does that kind of make sense?
And why is the 1 cosine next to negative 1?
Because I needed 2 times a negative 1 to make negative 2, and 2 plus negative 1 to be a positive 1. So then this 1 cosine must have come from 2 cosine to positive 2 minus 1 cosine to negative 1. With grouping, when we figure out the 2 factors that multiply to be the top and add to be the bottom, when this first coefficient is anything other than 1, I have to take this middle term and split them up into who he came from. And he came from those 2 coefficients. And then once I split them up, then I can look at these separately in pairs, which is grouping them in parentheses. Look at them separately and saying, who do you have in common? Who do you have in common? And if all has gone well, they will share a factor and I'll be able to finish. Does that make sense? So then up here, kiddos, we have it factored. How did that help? What did we talk about yesterday? In the example in our notes, when we had factors equal to 0. Set each one equal to 0. When we had factors equal to 0, set each one equal to 0. Which is what we're used to doing with quadratics. If this was x minus 1 or 2x minus 1 and x plus 1, we'd set each one equal to 0. Don't let the trick stop you from doing the algebra. When we set each equal to 0, this guy, you guys do algebra in your heads, add 1, divide by 2, right? So cosine of x is equal to 1, huh? Set this guy equal to 0, you're going to subtract 1 from both sides, right? So cosine of x is equal to? And then where are you supposed to go? You know this. Go here. Cheater chart, unit circle. Yeah. Cosine, isn't that the second row?
Yes, ma'am.
1, 2, 3. 3, 2, 1. Cool. So 3, no. 2, no. 1, yes. 60 degrees. Cosine is positive in the first quadrant, all, and in the calculus quadrant, fourth quadrant. 60 degrees is going to be pi over 3, and 5 pi over 3. Uh-oh. Stop. You guys help me out. This was from your homework. What were the directions in that section? Was it 0 to 2 pi, negative pi to pi, all the angles?
0 to 2 pi.
Okay, cool. So did I do the one 0 to 2 pi?
Yes.
I just went the normal one way around, found my 2 angles. But who did I forget in the process? Okay, so where is cosine negative 1? 3, 2, 1. Oh, it's the highest at 0, but that's a positive 1. So then at pi, it would be at a negative 1. A couple different ways of doing it. I did it cheater chart way. You could also think the order pair way. It's negative 1, 0, cosines the x. But my answers, my final answers would be pi over 3, pi, 5 pi. Now, time out. If you have those answers on your page right now, but you had no clue how to do the problem, did Did you really get this one? No. This is one that you would need to star in a colored pen to be like, hey, I'm weak on this spot, right? Don't go pretending that you understand things in the homework, and then you get to the test and you aren't studying your weaknesses. How's that going to help? You're going to still miss it on the wall. If you have the answers, okay, you checked on CalChat, you checked in the back of the book, but if you don't understand it, that needed to be a question for today. What was the key when we have a quadratic, meaning a squared, a single, and a number? What was the key? What was our process? What did we need to do? Factor. And to factor, A times C, split up the middle term, group, and then finish. Okay? Questions on 33? On the map or on the trig? Unit circle, algebra. Okay? Were there any other weird factoring ones in homework? Maybe one that said use the quadratic formula? Where? 60, what was it?
Oh, so 36.
Oh, 36 needed it? Sine over cosine, sine squared. Ooh, 36 wasn't a factoring one though. Hold on, let's go find a quadratic formula one. Ah, here we go. 59 through 62. You guys see the directions? Using the quadratic formula, I actually had a problem in the notes ready to go that we were going to do in the back of our spirals, but when I heard that you guys were stuck on this one, no, we did an example just like factoring with trig in section 5.1. That's why I want to say time out. Hold on. We lost it. We lost it somewhere in between 5.1 and 5.3. Some of you are just too lazy to look back. Some of you just, it's a hard problem and you got stuck. But let's go ahead and do, there it is, using the quadratic formula. But you guys tried homework last night, you got stuck. Let me get rid of number 61 and let's get number 60 instead, okay? That was the homework one, AJ?
Yeah.
Okay. Can you read for me what number 60 was?
3 tan squared x
Okay.
plus 4 tan of x minus 4 equals 0.
If you saw this problem after the one that we just did, what would you think of doing? Yeah, exactly, right? Draw an X. Okay, what would go on the top? Negative 12. What would go on the bottom? Okay, pause. Are you okay with that?
Yes.
First times last. 3 times negative 4 is negative 12. Middle term is 4. Okay, factors that make 4. Ooh, 2 and 6, right? Dun, 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 dun. Wait, it really said use the quadratic formula? Huh. Hold on, double checking real fast. Doesn't look like you need it. Okay, that's alright, we'll keep using it. We'll keep using it, we will use it. But first of all, how's my factoring looking, guys?
Pretty good.
Right? Negative 2 times 6, negative 12, negative 2 plus 6 is 4. So what would we do the factoring way?
3 tan squared x.
Rewrite the 3 tan squared. We use the negative 2 and the 6 to do what? Okay. So then, how many tan x's? Negative 2 tan x's. Plus 6 tan x's. And then rewrite the negative 4 equals 0. Now pause. You can always double check. Is negative 2 tan plus 6 tan 4 tan?
Yes.
Okay, I haven't messed anything up, right? I split it up and I'm ready to go. Okay, now what? Group them. Put them in pairs. What's in common?
2 10. Oh.
Tan x.
Tan x. What's left when I divide a tan?
3 tan x minus 2.
So you guys tracking? Bring back into tan. Tan times tan is tan squared. Negative 2 times tan is negative 2 tan of x. Okay, good. What's in common over here?
2.
Can I get a, you guys good with 3 tan x minus 2? Does factoring work on this one? Totally. Because you would end up with tan of x minus, plus 2 times 3 tan x minus 2 equals 0. So why did they ask me to use the quadratic formula? Factoring doesn't always work. Jacob, I'm coming back to your factoring question in just a second, but first of all, the point of this problem was to show that the quadratic formula can work too. And in, I think, number 61, factoring would not have been possible. We would have tried this and not found any pairs, not found any factors that added to B. And we would have been stuck. So there is another way. And the other way is to say, hey, A is equal to 3, B is equal to 4, C is equal to negative 4. Usually we say X equals negative B, but is X being squared in this problem? Who's being squared? Tangent. So instead of saying this is the difference, instead of saying X equals negative B, it's tan equals negative B. Plus or minus square root B squared minus 4AC. Thank you. Then we would go ahead and simplify. And some of you guys are already doing the math, because you have 4 and 4 is 16, 16 and 3 is 48, 48 and 16 is 50, 64. Double check me. Anybody else get 64? Oh, square root of 64 is, okay, let's just go there, yeah?
Oh, sure.
Is that okay? 64 square root of 8. All over 2 times 3 is 6. Plus or minus, do one thing at a time. So what's negative 4 plus 8? 4 all over 6? 2/3. And what's negative 4 minus 8? Negative 12 over 6 is, oh, careful. Negative 12 over 6, negative 2. What's going to happen when I keep going? If I was factoring, I set each one equal to 0, and I do my math of subtracting 2. Oh, tan equals negative 2, 4. I'd add the 2, divide by 3. People that like numbers, maybe you would have gotten there faster than us who were factoring. People that don't like numbers, okay, then do the factoring, it works. But sometimes if it doesn't, the quadratic formula is always a backup. I skipped over a question, Chris, and I think somewhere over there I missed yours too.
I have a question about the quadratic formula.
Sure.
Would this work on most of the problems? Yeah. Like,
All quadratics, yes.
It's not limited.
All quadratics, yes.
It's not limited to one.
Because this one was technically a nice one, so this one is okay with nice, but it also will be okay with gross. Like if this was square root of 62, there's no nice square root to that, and I'd still have my nasty decimal answers that my calculator would give me, but factoring could. Does that make sense? Alright, quadratic formula. Even then, we are not limited, but okay, we got to practice factoring again. I heard from you guys, Jackie, you didn't like which one? Number 36. Number 36? That's another even one. First of all, let's go ahead and go check what 36's answer is, since you guys weren't able to check it. But in order to get to 36, let's check some other evens also. So number 4. Ooh, extraneous. You guys find that vocab probably had to look for it a little bit? Extraneous? Can someone read me the definition? You're supposed to write it down anyway. Chris, what is it? Extraneous.
Extraneous doesn't satisfy the original equation.
So somehow, you get to the end, you think it's an answer from the math, and yet if you plug it back into the original, it doesn't work. Do you remember what other category of problems, like what kind of functions we were dealing with that had extraneous sometimes? Extraneous answers? I don't remember. Logarithms. Sometimes the math would make it look like an answer was legal, but if we plugged it into the beginning, the log domain restriction would be like, it's not legal, so we'd have to say extraneous. Okay, anyway, that was just a reminder of vocab. Number 14, you guys can see. This one wasn't supposed to be too bad, right? It's kind of like the first example in our notes. Combine like terms, solve. Unit circle would put me in 2 locations, and they wanted the infinitely many representations, the coterminals. Remember yesterday? The coterminal angles. Number 20. Ooh, did you guys see that 3x that was stuck inside?
Yeah.
Did you leave it in there like you were supposed to? It was stuck. So we had to deal with the squared, first of all, square root both sides, plus or minus. Then we had to deal with the tangent. Who used your cheater chart? Oh, that's it? Come on. I have you standing looking at it yesterday. Square root of 3 over 3, 1 square root of 3. Happens at 60 degrees, at pi over 3. And once you figure out it happens at pi over 3, you could have actually written this a couple different ways. The book makes this answer look weird. Why aren't you writing today? Just not writing at all. Try to marker. Alright. You could have also written this answer like, let's see, tangent would have equaled plus or minus pi over 3 at pi over 3, 2 pi over 3. It would have been in every quadrant. 4 pi over 3, 5 pi over 3. But all of those answers aren't equal to x. All of those answers are equal to 3x, like we saw in our notes yesterday when there's that nasty multiple argument on the inside. Got to get rid of the tangent first using unit circle, then divide everybody by 3 or multiply by 1/3. So what's 1/3 times pi over 3? 1/3 gets rid of him. And 1/3 times pi over 3 is pi over 9. We keep on finding more and more. 2 pi over 9, 4 pi over 9, 5 pi over 9. They just give us like a whole formula and say, you know what, you could have just written pi over 3 plus pi n and 2 pi over 3 plus pi n. The reason being is because tangent is positive in the first quadrant and also in the third quadrant. So instead of adding 2 pi to go all the way around, you can actually start at pi over 3 and say, hey, since they're across from each other, just add pi instead. This is a shortcut. Instead of having to write all 4 plus 2 pi n plus 2 pi n plus 2 pi n plus 2 pi n, because they wanted all the answers, we could have just written pi over 3 plus pi n. It would have gotten in the third quadrant and they'd keep on hitting the first and third. But the plus or minus says not just first or third, I also want second and fourth. So then they also wrote down the 2 pi over 3. And pi n to that guy would get in the opposite quadrant. So they ended up only having to write 2 formulas instead of 4. They were just shortcutting it. Mathematicians like shortcuts. And then they went ahead and divided everybody by 3. And that's how they got pi over 9 and then pi n over 3 or n pi over 3. Doesn't matter the order. Divide everybody by 3 and you end up with pi n over 3 or n pi over 3. But just in case, you could have also written this instead. You could have also had pi over 3 plus 2 pi n. Everybody divided by 3. Should have been n up there. But you could have written the second quadrant guy. It would have been 2 pi over 9 plus 2 pi n over 3. You could have written the third quadrant guy and all of his coterminals. And you could have written the fourth quadrant guy. But some of you guys that were kind of confused by why they used the pi n last night, do you see why they were really just being lazy? Would you rather write all 4 of those or just those 2?
Just those.
They were just shortcutting. But is this answer right?
Yeah.
Totally. Totally right. All 4 quadrants with all the coterminals and everybody divided by 3. Okay. That one was nasty, but we talked about that yesterday. This little 3x makes it a little bit longer, a little bit harder. Number 28. We're almost at 36. What? Why did they change sine squared? To be 1 minus cosine squared. To get a quadratic. It's a factor. Set each factor equal to 0. Units. So they had to transform it. And we had actually one of these in our 5.1 notes also, where we had a sine squared and a cosine, and we had to make this into a 1 minus cosine squared to use the factor. Now we're down to number 36, which is Jackie's question. Did anybody else, or did anybody in here, did you figure out tangent could become sine over cosine? That's what I would have done. But when you have tangent to sine over cosine, then sine squared over cosine. Wait, how did they get this? Remember, they do a lot of steps at once. Okay, then pause. Hold on. You got this. Because look, if you just multiplied this, wouldn't you have cosine of x plus sine squared all over cosine. Kiddos, how can we get this more together? No denominator, denominator, what can we do? Common denominator. So what would they multiply top and bottom by? Cosine over cosine. What's cosine times cosine? Cosine squared. They just got a common denominator, put it all together, and the reason they did that is, oh, booyah, hey, what's cosine squared plus sine squared? 1. Pythagorean property. So 1 over cosine equals 2. Solve, solve, solve. Cosine then equals 1/2 if you multiply up the cosine and divide the 2. Which is what we were doing yesterday. If you saw division, multiply to the other side. And then go to your unit circle, 0 to 2 pi. Cosine is 1/2. 3, 2, 1 at 60 degrees, or pi over 3 in the first quadrant. Does it feel like cosine equals 1/2 a lot?
Yeah.
Yeah, same here. Maybe they're trying to make it easier on you with the unit circle. Jackie, that makes sense? Yeah, cool. Next even, number 40. The algebra was actually super easy. Just subtract, divide, but then you had to remember, am I allowed to touch the 2 in here yet?
No.
I have to undo the sign first. I have to ask myself, when is sine negative root 3 over 2? Cheer chart people, 1, 2, 3 at 60 degrees. Man, everything's 60 degrees today. So then we took sine inverse of either side, figured out that negative root 3 over 2, sine is negative in the all or positive, nope, sine is positive, nope. Third quadrant and the fourth quadrant. Have the pi over 3, so I have all 3 plus 1, 4 pi over 3. I have 4 plus 1, so 5 pi over 3. Which is why they stole those 2 locations. They added the 2 pi n to each because of the all solutions, and then they divided everything by 2. But that's hard to divide by 2. It was a lot easier to multiply by 1/2, which is what I did yesterday. Now he's mad at me. So if you multiply by 1/2, I tried telling it that, but it doesn't really listen to me. Multiply by 1/2, the 2 and 4 reduce to be 2 pi over 3. The 2 and the 2 reduce to be pi n or n pi, either way. You do it to the other side as well. So this guy times 1/2 is 5 pi over 6 times 1/2, which is pi n. Super similar to what we did yesterday. Number 60, we've already done, and we did it the factoring way, but some of you like the quadratic formula way, except we didn't finish it because square root of 3 over 3, 1 square root of 3 is negative 2 and 2/3. Are those unit circle tangents?
No.
Oh, forget that. Go to your calculator, and they did. They used second tan. And remember, they didn't want to write all 4 quadrants. Sorry, all 4. They didn't want to write both negative quadrants and both positive quadrants, so they shortcutted it with that pi n. Tangent, you're allowed to shortcut. Because it's opposite quadrants. But sine and cosine are not opposite quadrants, so we can't use that trick, sadly. But arctangent, you can. But the other way of looking at it is you could have just thought logically. With the unit circle. Tangent's going to be negative all? No. Students, yeah, tangent's negative too. So when I get that first answer, which is a negative answer, that would be negative 1.1071. That's the fourth quadrant. I also needed the second quadrant, so I would have had to, this guy. Would have been negative 1.1071 plus pi. I would have had to add pi to get to the other quadrant. So I could have stolen that guy who's an answer and also stolen that guy. And when I got the 5880, that would have been tangent positive in the first quadrant. But I also would have needed the third quadrant. And how do I get over there, guys? Add. Yeah, just go halfway. Add pi. So adding pi to that guy would have been this guy. 0.5880. You didn't actually have to use this little formula. You could have just actually added pi to the second answer, added pi to the first answer. And the tricky thing on this one is you actually could have added 2 pi to find the last one, because this guy had 2 answers that fit. You could have added 2 pi. Would everyone want evens at the end of homework? One more? Oh, 86 and 94. 94 was the Ferris wheel one, right? Okay. I'm going to show number 94 on the screen. You guys can peek at it on the video. It's a little bit beyond where I want to go necessarily with you guys. It was good for a homework problem. It shows you the practical application of the Ferris wheel, and as it rotates, it's actually a trig function. But in number 86, it was just having you play with your graphing calculator, remembering you can actually graph the two sides of an equation and see how many times they're equal, how many answers there would be by the intersection points. And they didn't even make you find it. That was cool. They just said how many. Look at the picture. Look at the window. There were 3. There were 3. Number 94, let me get it up on the screen. That way it'll be on the video. Starting with the function, they say let it equal 53. So you could have used math or you could have used your calculator on that one. They solved and got 8 and 24. Then the person will be at the top when the sign is the highest it possibly can, which sign goes between -1 and 1. 1 is the highest sign can be. Then they solve using their trig and were able to get finally a period of 32. Which means in 160 seconds, 5 cycles will take place. Meaning the person will be able to go through the whole cycle 5 times before they have to get off. And then they let us know when the person's going to be at the top. After 16 seconds, 48, 80, 112, and 144, which is just adding those 32 seconds. So starting at 16, adding 32, adding 32, adding 32, adding 32. Okay, you guys need to check out the video if you want to look at that in some more detail. That's the end of the evens that we were grading. Were there any other odds that you guys had questions on besides 33 and besides, well, I guess 60 wasn't even and 34 wasn't even, or 36 wasn't even. Chris?
45.
Okay, and then AJ? 37. So let's go back to the previous page. We're not going to spend a lot of time, but enough to give you guys a hint. That should be able to allow you to see how chat as to why they did what they did. 37. What do you guys see? Can I combine those two?
Oh, no.
No. But what can I make cosecant? Careful. The C's don't go together. Yeah, 1 over sine. Plus, what can I make cotangent?
Cosine over.
I'm using this trick of changing everybody to sines and cosines. Because the nice thing of this one is once you change it, aren't those already common? You can't already add them? Then if I'm able to get them all together, it's going to be over sine, which I can multiply to the other side. I can multiply that to the other side. And now it's just like, well, how do I get it alone? Some people would think dividing. The problem is if I divide it, I'll actually get right back here and right back there. But good idea with dividing. I could subtract it. But here's what my advice would be. My advice would be if you want to really get the trig all alone, you're going to have to get the Pythagorean property involved, which you can't do until you square both sides. And if you square both sides and don't kill a puppy in the process, I remember doing part of this one yesterday. I don't know why. Maybe it was in period 5, but you guys were ahead of them. If you square it, I can't change. I have lots of cosines, but what can I do to sine squared? 1 minus cosine squared, and then I can have it all with cosines. I'm going to have to factor. I can make sine squared into 1 minus cosine squared. So I have this on one side, this on the other, move it all to one side, you have a quadratic. That's 37, and then Chris, yours was 45? X-intercepts are when y equals, so you're going to subtract the 1, ask yourself the question, when does sine equal -1? That's going to happen at, sine is the 3 pi over 2, I think. So you're going to set pi x over 2 equal to 3 pi over 2, and then solve for x. The other way is that you could have, though, graphed it and found the zeros. It just wouldn't have been nice radians. It would have been nasty decimals. But you could have graphed it and found the zeros. It would have been the same decimal, just not good. Okay, those are the end of the homework questions. Now, long story short, when I do a spot check tomorrow, should we be totally good on not just showing the answers, but showing the work that gets you there? Yes. Kiddos, I know that I have to let you go in about 30 seconds, but why did we spend so much time on today's homework? Well, let me show you this. In section 5.4, do you guys see some new formulas? 5.4 and 5.5, there are no new types of problems. There are only new formulas to use in the problems, meaning we're going to be doing stuff like 5.1, just playing and changing. We're going to be doing stuff like 5.2, t-proofs. We're going to be doing stuff like 5.3, solving equations. Those are the types of problems till the end of chapter 5. But what's new is we have, instead of just that one table of formulas, we're going to have some more to play with. Okay? So I wanted to make sure that we knew how to solve equations in 5.3 because we're going to have to be doing those same 5.1, 5.2, 5.3 types of problems with new formulas to finish. Okay? Get out of here, make sure your 5.3 is ready for tomorrow's spot check. And I'll see you guys in chapter. If you brought a book, I would love it back. Actually, I need it back. You guys got coffee and stuff?
We won by like 3. Oh shoot, really? We were down the whole game.
Yeah.